Okay, hello everyone, welcome. Can you hear me? Okay, thank you. Just we're waiting 1 minute for joining all of other participants, then we'll start. Okay, so we'll start today's session. So basically, today is our sixth number test, and mainly today's session I discuss about that land use land cover classification using machine learning in Google Earth Engine. How we can really apply the different types of machine learning, and then perform the land use land cover classification. Okay, okay. Let me share my screen. Okay, can you see my screen? Is it visible? Okay, thank you. Okay, so basically today's session we discuss about that introduction to machine learning in Google Earth Engine. So how we can easily apply the different types of machine learning method. It can be supervised or unsupervised, and make the land use land cover classification. We also discuss about that, and how to make the land use land cover using supervised machine learning method, or land use land cover using unsupervised algorithm. Okay, and we will discuss about the random forest algorithm, then card algorithm, basically classification and regression trees algorithm, then SVM, basically support vector machine algorithm, then minimum distance algorithm, how we can easily apply and make the land use land cover classification. We also discuss about that, and after making the land use land cover map, we also discuss about the accuracy assessment, how we can easily make the check the accuracy. Okay, so overall accuracy, then kappa accuracy, producer accuracy, so consumers accuracy. So this type of accuracy, how we can check, we also discuss about that, and how to calculate land use land cover classes area, we also discuss, and how to listen on your land use land cover map, and how to export the land use land cover map. Okay, so let's go ahead and discuss about the all of things from beginners to advanced level on land use land cover classification. Then I hope you can easily get the idea, and then you can easily apply it. Okay, so let's go. So in this case, where you had the machine learning in Earth Engine platform. So basically machine learning is a field of artificial intelligence that enables system to learn from data without explicit programming. So it focuses on developing algorithm that can identify pattern, make prediction, or improve their pre-performance over the time through the experience. So basically, we find out the machine learning. It can be two types, mainly two types: supervised and unsupervised machine learning model. So supervised, basically when we apply, then we need to create the pre-categorized data, or we need to create the training sample for each classification classes. Suppose in the supervised learning, when you make, suppose I want to make the land use land cover, so then we need to make the pre-categorized data, or we need to identify for classes. So this one is for suppose cropland, this one is for barren land, this is the build up, this is the vegetation. So this type of classes we need to create before applying the classification. But when you apply the unsupervised classification, you don't need any kinds of pre-categorized data or any kinds of label data. Okay, you don't need. But when you apply the supervised learning, then you must need the pre-categorized data or label data. We need to set the label. Suppose this is the water body, this is the build up, this is the vegetation, this is the barren land. So this type of label data we need to generate when we apply the supervised classification. But unsupervised classification, we don't need to generate this type of label data or pre-categorized data. We don't need. Okay, so further let's discuss about the more details about that. And now, what is the classifier? So basically in Google Earth Engine, we find out some ready-made machine learning algorithm. So this type of ready-made machine learning algorithm called as a classifier in Google Earth Engine. So classifier is it's one kind of algorithm, which algorithm we implement in our data set. So the algorithm which we implement the classification on a data set is known as a classifier. Suppose random forest is one kind of classifier. Support vector machine is one kind of classifier. Or card or classification trees, it's one kind of classifier. So this type of algorithm called as a classifier. Okay, in Google Earth Engine, it's called as a classifier. And basically classifier can be two types. It can be binary classifier and multi-class classifier. My binary classifier, basically this possible outcome only for two. We find out the only for the two possible outcome when you apply the binary classifier. Suppose I want to classify only for forest and deforestation, forestation and deforestation. So this it's one kind of binary classifier example. Okay, as well as suppose yes or no, male or female, spam not spam, just only for the two possible outcome. It's called the binary classifier. And multi-class classifier, if a classification problem has more than two outcome, then it is called as a multi-class classifier. Suppose land use land cover classification.
Excuse me, sorry, you are not sharing your screen.
Just a minute. I think it automatically stops the sharing sometime. Yeah, just a minute. So we find out the two types of classifier: binary classifier and multi-class classifier. So binary classifier, it possible outcome, two outcome, only possible two outcome. Suppose when you work with only for the forestation and deforestation, it's just only for the two class. Or multi-class classifier, if the classification problem has a more than two outcome, then it is called as a multi-class classifier. Suppose crop types, or the different types of crop I want to classify, or classification of land use land cover, different types of classes. Okay, then it's a multi-class classifier. And what is the classifier? Classifier, it's one kind of algorithm which implement that classification on a data set known as a classifier. Suppose support vector machine, then cart or minimum distance. This is one kind of classifier in Google Earth Engine. And now how I can apply the supervised learning classification. So when you make the supervised classification in Google Earth Engine, so it define on some step. So first step, you need to selecting your study area. So this is the first step when you make the land use land cover classification using Google Earth Engine. Okay, just simply make the your study area, simply import your study area, and then you can easily import your study area in your asset tab, and then you can easily work. Then filtering and choosing. Okay, suppose first of all you choose your image collection, then filter your image collection. Suppose if you want, you can use here the Landsat or Sentinel, both are the same process for making the land use land cover classification. Just simply choose and then filter your image collection. And then for the supervised learning, we need to collecting the training sample. Okay, we need to collect the training sample for each classes. Suppose you want to make the land use land cover classification for build up, vegetation, barren land, water body, then we need to take the training sample for this type of classes. Okay, and then we need to merge all of training sample together, and then selecting the bands for creating the features. So in this time you can select the different bands in your from your satellite imagery, as well as you can also add some external band for creating the features. And then we are just create a data set. So this data set, further this data set simply split into training and testing. Suppose 80% data for train your model and 20% data for test your model. Okay, then create the classifier using the train, and then train your model using the train data, and then model connecting with your satellite imagery, and further create the classified images, and then display the result and also check the accuracy assessment. So this is the overall step. So I will try to show the practical example, then you can also get more better idea for creating the land use land cover classification. So okay, let me open a code editor. So first of all, you need to import your study area, which area you want to make land use land cover classification map. Okay, so simply import. So suppose I want to work for, suppose Dhaka city, simply import. So this is my boundary. I put the name as a ROI, you can put any name, and then I want to display this shape file, and then focus on my given study area. And run the code. So now I find out my study area. So this study area I want to use for making the land use land cover classification map. So now first step is done. Okay, then second step, we need to choose and filter our image collection. So in this case, you can choose the Landsat or Sentinel. Landsat and Sentinel are the same process when you make the land use land cover classification map. Basically, we find out the Landsat, it's available from 1973. Okay, and Sentinel 2, it's available from 2017. Okay, or 2015 or 17, we find out the Sentinel 2 sensor. So this is the Landsat. Suppose when you work with historical data analysis, when you, okay, just a minute, it also removing. So when you work with historical data analysis, then you try to use the Landsat satellite imagery. Okay, and when you work with suppose present time or current situation without making the historical data, then try to use the Sentinel 2 satellite imagery. Okay, and Landsat, this resolution is 30 meter, and Sentinel, this resolution is that we find out that 10 meter. Okay, so Sentinel 2, it's provide you the more better land use land cover map with better accuracy than Landsat collection. But Landsat, this image collection is available from 1973. Okay, but Sentinel 2, this image collection is available from 2017. Okay, so now depend on your research works, simply choose your image collection, and then further filter. So in this case, suppose I want to work for, in this case I want to work for suppose Landsat satellite image collection. So for that, simply click on the browse data catalog, and then click on the Landsat, and Landsat 9, Landsat 8, Landsat 7, Landsat 5, all of the same process. So basically it defines the time period. So you can see different time period. So we need the different types of Landsat image collection. So I want to use suppose Landsat 8, and you can see basically when you work with surface reflectance for like making the land use land cover classification, then we find out the more better result. Okay, so I want to use the surface reflectance satellite imagery. So here we find out all of information. So now this is my image collection. So now we just simply filtering, and we already know about that how we can easily filter this image collection. Just I copy the snippet ID and then paste in my code editor, then give a variable name. You can put any name as a variable. I put the name suppose image. Okay, so now this is my image collection. So now I need to filter. Okay, so how I can filter, we already know about that. So just put here filter bounds function for intersecting with your study area RY, then put here suppose filter metadata. So I choose cloud cover less than, I set 1, and then put here filter date. So now put the time period. I put suppose 2025-01, and I keep suppose last time period, which is 2025-06-26. Okay, so this is my time period. I simply choose. So now if I check how many images are available between this time period for my study area, less than 1% cloud cover. So now it's we find out the total 6 images. Okay, so now if you want, you can work with single images for single time period images. So you can also do it. Suppose just simply print this image, then we find out all of image information, single image information. So from here we can simply choose the any single imagery. Suppose I want to use the imagery, then simply copy the ID and then paste, then we can easily find out the single date imagery. Or if you want, you can create the median composite, then we can also work with that. So median composite, basically it take total 6 images, middle pixel and create the composite. So I want to apply suppose median composite, but if you want, you can also use the single date imagery and also make the land use land cover, same process, and then clip with my study area, which is RY. So now we just try to add the imagery and check the result. Just add a layer, map.add layer of this image and run the code. So now it's added a layer. We find out this type of imagery. Okay, so this layer. So we try to add the visualization. In this case, if you check, it shows the digital number. So I want to convert into reflectance value. So for that, we need to use the scale and offset value. Okay. So for that, you can simply use here dot multiply function, multiply with the scale value, because all bands are the same scale. This is the scale. Just take copy and also add with offset value. This is the offset value. Okay, all bands and all offsets are the same for all bands. Just take copy and add. So now run the code. Okay, now try to add the visualization. So I want to add here suppose red, then green and blue. It's called the natural color. Stressing 98% and apply and import. So this is my visualization parameter variable. Just copy Okay, so now we find out this type of imagery. So this is our satellite imagery. So I want to use this satellite imagery and make the land use land cover classification. Okay, to identify for different types of land use land cover classes. So now after generating this type of imagery, we need to follow the third step. In the third step, we need to take some training sample. Okay, we need to take some training sample for different classes. Okay, third step. Okay, so now in this imagery, suppose you want to classify water body, build up, vegetation, and barren land. I want to classify it. So then we simply take the training sample for this type of features from this satellite imagery. Or if you have the ground truth data, so previous class I discussed about that how we can easily import the CSV file in our asset tab. Same process, just simply apply and simply import your ground truth features. Okay, suppose you have some data for water body, some data for cropland or vegetation, anything. So then this type of CSV file simply import and then we can also work with that. Okay, so in this case I take the training sample from this satellite imagery, and when we take the training sample from satellite imagery, we can use different types of band combination to identify different types of features from satellite imagery. So now it's called the natural color. So natural color, we find out this type of images. So this imagery, we find out that vegetation show as a green color. Okay, we find out this type of place is the barren build up. Okay, we identify. Okay, this is the vegetation. Okay, we can easily identify. So it's one kind of true color band combination. Actually, what our human eye can see naturally we can see this type of things. But when we apply the another band combination, it's called that false color band combination. Suppose I apply for near infrared, then red and blue, stressing I keep 98%. So now it show me the another imagery. So this imagery I can easily identify for water body. So now water body show as a black color. Okay, in this imagery. So this type of black color or dark color identify for water body. Okay, so when I apply this band combination, near infrared, red and blue, and it also applicable for Sentinel-2 satellite imagery also. Okay, so any satellite imagery we can easily apply this band combination. Then we find out this type of features, this type of imagery. We can easily identify this type of black color or dark color identify for water body, and this type of red color it's identify for vegetation. Okay, better red color identify for better vegetation. We can easily identify this type of place is the vegetation. And if you check this type of gray color, it's indicating about that your barren land. Okay, we can easily identify this type of band combination. So any study area, when you apply this band combination, always we find out the water body as a dark color or black color, this type of color. Vegetation show as a red color. Okay, and this type of gray color identify for barren land. Okay, this type of gray color we identify as a barren land, and this type of red color identify as a vegetation we find out in here. So this is the another band combination. Or if you want, you can also apply suppose short wave infrared one band, then near infrared and blue, stressing 98%, and now apply. So now you can easily identify it, show the another image visualization. So now you can easily identify this type of place green color indicating about the vegetation. Okay, we can easily identify it's a vegetation. This type of black color indicating about that water body. Okay, and this type of gray color indicating about the barren land. We can easily identify. So not only for that, if you search on the Google, then we find out the lot of band combination to identify for different types of features from satellite imagery. Okay, so now we can simply use this type of band combination to identify from that different types of features from our satellite imagery. So now I can easily identify this is the water body, this type of place is the water, also this type of place is the water, this type of place is the vegetation. Okay, this is the place for a barren land. I can easily identify when I apply different types of band combination. So first of all, getting your imagery, after get the imagery, just simply apply this type of band combination and identify different types of features. So now we take the training sample. I think I need to update my system, okay, on the Google Chrome system. So then I hope it will be not occurred. Okay, so I will update after the class. Sure, okay, so now we just take the training sample. Suppose I want to take the training sample. So how I can take the training sample? So now for taking the training sample, we are just create this type of point feature. Suppose I create some point feature, and this type of point feature indicating about that training sample. So just click on the add a marker, so you can see it show the geometry. Okay, so just I click on the edit layer properties and I give a name. So you can put, I take the training samples for water, so I take the name suppose water and import as feature collection. So I set the property. So property I keep the same for all classes. I put the class, you can put any name as a property, and I set the value, I set the value 0. So you can use any value. So I put the 0 first for 0. So 0, it's one kind of label. So I just create the label. So water, for the water I set the level is 0. Okay, so then I just okay, click on the okay. So now I can easily take some training sample from my imagery. So just I take this type of place is the water, take the some training sample, and also have this type of place is water, just take the training sample. Okay, also I have, and how much training sample I take for each classes. So basically it's depend on your accuracy. Okay, okay, so suppose if you get not much very good accuracy, then we need to increasing or decreasing this type of training sample. But first time you try to take more than 30 or 50. Okay, depend on your study area. So in this time I just work with a small study area, it's not much big. So I think 30 is okay for my study area, greater than 30. Okay, but if I check the accuracy is not more better, then we try to increase the training sample again. Okay, but first time you try to run your model greater than 30 or 50. Okay, for each classes, and then check the accuracy. If you don't get the better accuracy, then we need to modify the training sample again and then increasing or decreasing the training sample. Okay, so I take the training sample for the water body, then just click on the new layer and take the another. Suppose I take the training sample for vegetation. So same, I put the name suppose vegetation and import as feature collection. I set the property name is the same for all classes. I put the class and I set the level for vegetation is 1. 1 means vegetation. I set the level 1. So now you can see vegetation is selected. This vegetation is select, and now I take the training sample for this type of vegetation area or green color area. Okay, suppose I take the training sample for the vegetation, then I take the training sample for barren land. Just click on here. Set the property class and I set the label 2. Okay, so now I take the training sample for the barren land. Okay, so I take the training sample for build up or settlement. So for that I try to use for another band combination. Suppose I want to apply for a natural color. So natural color, it reflects the build up or settlement is more better. So just I put here red, then green and blue, and apply. So we find out this type of things. So basically this type of features, it's a barren land or settlement. So just take the training sample. So just click on here again, click this properties. I put it say suppose build up and put the property name as a class and set the value for 3. Okay, so now we take the training sample. Okay, I thought I take this type of training sample for the build up. So I want to create the total 4 class. So that's why I simply take the training sample for 4 classes. And if you check in our code, it also added this type of water, vegetation, barren land, and build up. Okay, so this is our third step to take the training sample. So now in the fourth step, merge. So just we merge all of training sample together. So then just take a variable. Suppose I put the variable name is that samples and simply merge all of training sample together. So for that, just I call the water and put here that merge with vegetation. Then it merge with bare land. Then merge with build up. Okay, simply merge. So now all of training sample we are just merge and store it in this variable. So now let's check and run the code. So now it show you that how much training sample I take. So it show the result. Total 160 training sample we take in now from this imagery. And if you check it's a features. So all of imagery, all of points have a value or label. If you check the label, so you can check this is the label for 0. Okay, so for it means that for this coordinate or for the geometry I used for take the training sample as water body. Okay, 0 basically water body. So when I take the training sample, I set the label for 0 for water. So if you check the another, suppose you can see this training sample, it show the property class 2. So it means that for this coordinate or for the geometry, this geometry I used for which class, you can check 0, 1, 2. 2 mainly barren land. Okay, so I use it for barren land, train the barren land. So I create this type of label. Okay, I create the label for each classes. So now we need to create the features. Okay, we need to create the features. So for the features, we need to create the prediction bands. Okay, we need to create the prediction bands. So which bands we try to use in here? So this Excel file, previous class I discussed about that. Suppose you have some Excel file about this type of data as a CSV file. So this CSV file we can simply import, and your CSV file must be unique basically individual. Suppose for the water body you make the one file, one CSV file. Then vegetation, make the another CSV file. For the barren land, make the another CSV file. For the build up, make the another CSV file. And now this type of CSV file simply import in the Google Earth engine, and further simply import from here. Suppose this is my water body, just I click, you can see it will be imported. Then I put the name, suppose it's a water body. Okay, then apply the same process. Okay, then apply the same process, simply merge all of training sample together and also make the analysis. Okay, so simply merge all of training sample together in here. So we find out that total training sample is 160. We find out the total training sample is 160. Then we can easily get the result from here. Okay, the same process, just simply upload the CSV file in here. Okay. Okay, just a minute, I have an urgent call, then I come back. Just a minute. Okay, so let's go. Okay, so now we create the features for this type of training samples. So further we need to create the prediction band. Basically this type of bands I extract the pixel value. Suppose for each point I extract this type of pixel value from this imagery. So for that I need to create a features. So take a variable, suppose bands, and make a list all of bands. Okay, which band I want to use as a features. Okay, so for that I simply take suppose SR B1 band. I also take SR B2 band, then SR B3 band, then SR B4 band, then SR B5 band, then SR B6 band, and I also take suppose SR B7 band. Okay, so just I take this type of bands and I want to use this type of bands, extract the pixel value for all of training sample. Okay, and this is my data set. Further we also add some external band also to get the more higher accuracy mapping. So now I just try to use this type of bands for extracting the pixel value from this type of points. So for that just take a variable. Suppose I put the variable name is that training and call my image. So this is my image. This variable stored the image. This variable stored the image. So from this image I just use the select function and select the specific all of bands. So this is my bands, and now I want to extract the pixel value. Okay, so previous class I discussed about that how we can easily extract the point pixel value. Same function we also use in here, same function. So just apply here the sample regions. Basically now I have sample, so this type of sample. So just I use the sample regions and then apply this function. So first of all collection, basically this collection it comes from the samples. I have total 160 samples of training samples. And then properties, second argument is the properties. So this properties it's come from here because I already have the property. I set the property class. So then just use here the class. Okay, and then also apply here the scale. Scale is 30 meter. Okay, so now this variable store it all of training data. So if I just print and call the training and run it, so now all of training samples extract the pixel value. This type of bands pixel extract. If you check, so if you check it, click on here from the features. If you check, suppose this we find out the properties, we can check, we find out that all of band pixel value from here we can easily find out. All of band pixel value we can easily find out. And what is the level? Level is the 0 for water. So if you check another point, if you check, so it extract the all of training sample. Okay, so now I want to add this type of B1, B2, B3, B4, B5, B6 and B7 bands. So that's why I find out only for this type of band. So further after some time I'll show you that how I can add that different types of external band. Suppose NDVI or NDBI. So when I add the NDVI, so then all of training sample also extract the pixel value for NDVI. All of training sample also extract the information for NDWI or EVI or any band. When you add, then it easily extract this type of things. So now we find out this type of training sample. If you check, so sometimes this type of data when you work with deep learning, this type of data we need to extract. Okay, we need to download this type of data. So same process you can also download from here. This type of data, just export the CSV file. Okay, this type of data, simply export the CSV file. Further we can just use this type of data using deep learning model, using the Python or Crash or this type of, or TensorFlow, we can easily apply this type of data for more deep and learning analysis. We can also do. So this type of data we can also generate from Google Earth Engine and download this type of data as a CSV file. Okay, suppose this type of data we simply download as a CSV file, and further we can easily use it in the others deep learning model or others any model. You can easily use it. So now this is my properties. So this is the properties, all of the properties, and this is the label. This is the label. So label 3. What is the 3? 3 mainly build up. So this type of property I use for level 3, a specific point. Okay, so now this is my data set. So this data set I need to spilled. Okay, suppose this is the full data set. So this data set I need to spilled. Suppose 80% that I want to train my model, and 20% that I just use for check my accuracy or test my model. So for that, this is the fifth step. In the fifth step, we simply spill the data randomly. So for that, just apply a function, take a variable. Suppose I put the variable name is dataset, and call my total dataset. Okay, so just call the training because it stored all of data. So now I just randomly distributed this data. For the randomly distribution, just use a function random column. Random column. So now we are just simply spill the data. Suppose 80% data for train our model. Okay, and then 20% data for test our model. Okay, so now we simply spill the data 80% and 20% from this data set. Okay, after randomly distribution, we simply spill the data 80% and 20%. Okay, so for that we simply take a variable. Suppose I put the variable name is that train set. Okay, just I call the train set and call this data set. Okay, call this data set, and now this data set I filter and keep only for the 80%. Okay, so just put here filter